we are going to recap the laws of indices. And so for our first question, we have x to the power of 7 multiplied by x to the power of 8. Now, what does this mean? So if we just highlight the x to the power of 7, that means that we have 7 x's, and they are all being multiplied together. So we have 3, 4, 5, 6, 7. So that's what x to the power of 7 represents. So we write the little 7 just to remind us that there's 7 x's being multiplied. But we don't want to write all 7 out, it'll take a while. Now, we also have the x to the power of 8. And very similarly, that means that we have 8 x's multiplied together. 1, 2, 3, 4, 5, 6, 7, and 8. And there's one thing from this expression that we've not actually looked at. In the middle, there is another multiplication sign. And so we do need to include that. So that's going to link the two sets together. Now, if we can change x to the power of 7 into 7x's multiplied and x to the power of 8 with 8x's multiplied, then how many x's do we have here? Well, we've got 15. So we can say if we've got 15 x's being multiplied together, we can call that x to the power of 15. So we're not spending ages writing out loads and loads of x's that are being multiplied together. So our answer is nice and simple. Now, you don't want to be writing this down every single time, and then you get to negative numbers, and that can make this method a little bit more confusing. So what do? Well, we use the laws of indices. And the first law is that if we are multiplying two lots of x together, and they've got different powers, so the first one has the power a, and the second one has the power b, then we can simplify that to an x that is the power of a plus b. And if you have a look at what we've just done, we had x to the power of 7 and x to the power of 8, and we ended up with x to the power of 15. So essentially, we can replace all of that working out with 7 plus 8 equals 15. Moving on to the next question, we're going to think about another one of the laws of indices. Now, if we multiply numbers and then we add the powers, then we're going to do something similar with divisions. So you've got an x, and it's being divided by another x, but they've got powers. So the first one has a power a, and the second one has a power b. Then think about, we're dividing instead of multiplying. So this rule, instead of adding, we're going to be taking away. When we look at the question, they've both got the same base number. They've both got x, and they've got different powers. And we have a division symbol. That means we are taking the powers away. Big thing to be careful here of is have a look at the negative numbers and the takeaway sign. There's going to be a little bit of confusion there. So we need to write this out really, really carefully. So firstly, write out the first power, which is representing A, that's the -4. Then leave a gap and write down the second power, representing B, which is the -1. Then figure out which other laws of indices you're going to use. So we are dividing them, so it's going to be a takeaway. So we need to put a takeaway in the middle. Now it's important to do it like this because you'll then notice we have a double negative. We have -4, take away -1, which can get a little bit confusing. We've got two negative symbols next to each other. They're going to cancel out and give us a positive symbol. So that's going to be the same as -4 plus 1. And now we have -4 plus 1. We can calculate it. So -4 go one higher. It's going to be -3 going towards 0 on the larger numbers. And what we've calculated here, this is just for the power. So what we need to do now is write down our final answer. So x to the power of -4 divided by x to the power of -1 is going to be equal to x to the power of -3. That's the same -3 that we just calculated. Now, for the next question, we have 1 over x squared. Let's do that a little bit larger so we can do a bit of working out if we need to. Now, with that, you might think, oh, is it going to use the division rule? But the thing with the division rule is that they both have the same base number. They both have x as a base. So the two numbers you're dividing, they've both got an x in. Now with this, the numerator is a 1. There's no x there. But the denominator does have an x. This is going to be a different rule. Now, the rule for this is it's quite simple. If you have 1 over, and it's an x term, so let's say x to the power of a, you can rewrite that without the fraction. And the way you do it is you write x to the power of negative a. So all we're saying is that the 1 over is exactly the same as the negative of that index. So when we look at our question, 1 over x squared, then that is the same as x to the power of negative 2. Now, you don't have to take my word for this. We can kind of prove this with a little pattern, and this might help you remember a few of these facts. So I'm just going to draw a little table to show that this is true. So what we're going to do is we're going to take 2 as an example. So we're going to have 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. And then we're also going to do the direction. So 2 to the power of 1, 2 to the power of 0, 2 to the power of negative 1, and 2 to the power of negative 2. I'm going to work out each one, starting with the larger ones. So we know 2 to the power of 2 is 4. 2 to the power of 3 is 2 times 2 times 2, which is 8. And if you think about this as a pattern, every time we go larger, we're multiplying by another 2. So 2 to the power of 4 is an extra 2 multiplied, so 8 times 2 is 16. So in this pattern, as we go to the right, we are multiplying by 2. That means that as we go to the left, we are dividing by 2. So 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. And this comes to our first little rule here, kind of 2 to the power of 1 is equal to 2. So basically, if you don't see an index, it's to the power of 1. Dividing by 2 again, 2 divided by 2 is 1. And now we have another little rule. Anything to the power of 0 is 1. And you can try this with 3s and 4s, but if you use this pattern, you're always going to get a 1 there because you're dividing it by itself. So we'll write that down as another rule. X to the power of 0 will be equal to 1. And we can keep going. So 1 divided by 2 is a half, and a half divided by 2 is a quarter. Now, look at the pattern that we've got here. So in our question, it was 1 over x squared, and that became x to the power of negative 2. So let's have a look at the 2's. When we have 2 to the power of 2, then we have a 4. When we have 2 to the power of negative 2, it's a 1 over 4. So what this is showing is that you can end up with the same numbers if it's positive or negative. It'll just be the negative version will have a 1 over as a numerator. And you can see the same thing, 2 to the power of 1 being 2, and 2 to the power of negative 1 being 1 over 2. Now, moving on to the medium questions, we have some more complicated expressions, but the core of it is the same. We have two terms that have an x as a base of the number, and they have a power. The extra thing here is that they have the extra coefficient at the front. They have the extra number. So the way to do this is to do the whole numbers and the indices separately. So let's do the indices first, since that's what we've been working on. So we've got a third, we've got 3/5, and we are multiplying the two terms together. So that must mean we are adding the indices. Now you can use your skills for equivalent fractions here. Maybe you might have a calculator with you, you can use that. A little bit of practice. Let's just multiply these by each other to make the denominators the same. That should give us 5/15 plus 9/15, and altogether that is 14/15. So that's the power sorted out. The next thing is the whole numbers. Now, with the whole numbers, all I need to do is use normal rules. They're not indices, they don't follow the laws of indices. So we've got 5 and we've got 6. 5 times 6 is 30. So our final answer is 30x to the power of 14/15. So again, do the normal numbers, the whole numbers using normal rules, and then do the indices using the laws of indices. As long as you can see highlighted in green, the base number is the same. So in this case, x. So for the next question, again, we can see we've got the kind of base letter or the base number in both terms. So we can use laws of indices, and then we've also got some normal whole numbers in there. Write out the laws of indices separately so you don't get confused with negative numbers. And in this case, we've got fractions. So you can use any fraction skills you might need to use. So we have 7/8 and we have 3/5. And since the numbers are being divided, then the laws of indices means we are taking the indices away from each other. Now, again, I'll just quickly run through fraction skills here. So let's multiply them by the denominator of each other to make them be equivalent fractions. So multiply by 5, we've got 35/40. And multiply by 8, we've got 24/40. I know the denominator is the same. We can do the takeaway, and 35 take away 24 is going to give us 11. 11/40. So now we've worked out what the index is going to be. We can have a look at the whole numbers, use normal rules. We've got 6 divided by 2, which is 3. So the final answer will be 3x to the power of 11/40. And a separate step for the whole normal numbers using normal rules, and then a different step for only the indices using the laws of indices, and then just combine them both together for the final answer. Now, for the next question, you can see we've got a quarter x to the power of 3, and it's all in brackets, and then there's another index, another power, the 2. Now, if you have two sets of indices like this with a bracket in between, there's another law for us to follow. So if you think about it, if you multiply, then you'll be adding the powers. If you're dividing, you're taking away the powers. Now, we've not looked at multiplying or dividing, and multiplying is what the brackets does. So if we have a power, let's say x to the power of a, and that's in brackets, then all of that is to the power of b, then that is the same as saying x to the power of a multiplied by b. So when we take a look at our question, we can see x to the power of 3, and then it's the power of 2. So that is going to give us x to the power of 6, because we've multiplied the two indexes together. Now, where a lot of students go wrong with this question is what we do with the quarter. You might be tempted just to write the quarter in, a quarter x to the power of 6. Now, what that power 2 means is that everything inside the brackets is to the power of 2. So the x to the power of 3 is to the power 2, but also the quarter is to the power of 2. So we're going to do a quarter multiplied by a quarter. Now, if you have 1/4 being multiplied by itself, another quarter, that'll make it squared. You remember how your fractions work, multiply the numerators and the denominators. We have 1/16. So the final answer is going to be 1/16 x to the power of 6. Now, next we're going to look at combinations of using the laws of indices. And the first thing to look at is what happens if you have more than one question stuck together. So in this case, I'm just going to write out the first part of this question. So we have x to the power of 4 divided by 5x to the power of 8. Now, I know after that we have another divide sign and we have the 4x to the power of 4. We'll also do one step at a time here. And if you think about bid mass rules, they're all being divided. It's all the same level of bid mass. So it doesn't really matter which order we do this in. Firstly, have a look at the normal numbers we have here. We've got a 1x to the power of 4. We can write the 1 in. Okay, we don't normally write the 1s like this in algebra. And then we've got the 5. So 1 divided by 5. We don't need to do it. You can leave it as a fraction. We've got 1 divided by 5. It's a fifth. Once I've done that, let's have a look at the indices. Again, I do recommend writing these out. So we've got 4, we've got an 8. And if we're dividing the whole numbers, we'll be taking the indices away from each other. 4 take away 8 is -4. So let's write in the power. We've got a fifth x to the power of -4. So now I've worked out the first part. Let's take that answer, a fifth x to the power of -4. And now let's do the second part of this. So I'm just going to cross off. We've done the x to the power of 4, and we divided it by 5x to the power of 8. So what we've got left is we have the divide symbol, and then we have the 4x to the power of 4. And now I'm just going to do the same thing again. So firstly, we're going to have a look at the whole numbers, or in this case, we've got a fraction now. So what we mean is the coefficient's the number before the x. So we've got 1/5, we've got 4, and we are going to divide them by each other. So again, I'm just going to revise some fraction skills to do this. And a little tip is with the 4, write it as a fraction. And what you do with a whole number is you can write it as a fraction over 1. 4 over 1, or 4 divided by 1 is the same as 4. Good method for dividing fractions is to keep it, change it, flip it. So we're going to keep the first fraction the same. We are going to change the operator from a divide to a multiply. So just kind of doing the opposite. And then we're going to flip the second fraction upside down. And that's doing the opposite as well, isn't it? We flipped it upside down. So if you make the fraction be the opposite way around and the symbol be the opposite way, they're going to cancel out and give you the same answer. So a fifth times a quarter, 1 times 1 is 1, 5 times 4 is 20. So we've got 1 over 20 as our answer. So going back to our question, a fifth divided by 4 is a 20th. Then we can look at the indices, again, write them out carefully. We've got -4 and a 4. And if we're dividing the coefficients, then with the index, we're going to be taking them away. -4 take away 4 is -8. Our final answer is 1/20th x to the power of -8. So as you can see here, lots of different elements being brought together, lots of, algebra skills we've not seen the one, fraction skills, and laws of indices. So for the next question, we have the same thing. So we have 3 different terms here. The first 2 being multiplied, 1 as the denominator being divided. Just do 1 step at a time. So I'm going to take the top row, the numerator first. We've got the 4x to the power of 6 multiplied by 3x to the power of 3. So do the whole numbers first. 4 times 3 is 12 using normal rules. And then do the indices using the laws of indices. They're being multiplied to add the powers together. 6 plus 3 is 9. And there's no negative numbers or anything confusing here. So nice and easy. Take your answer and just check what we've done so far. So we did the 4x to the power of 6. We multiplied and we did the 3x cubed. What we haven't done is the divide symbol. So sometimes it's been written as a fraction like this. It's still a divide. And we haven't written down the 6x to the power of 6. So again, whole numbers, normal numbers, use normal rules. 12 divided by 6 is 2. Then the indices, use the laws of indices. And it's a different one this time. When we multiplied, we added the powers. Now we're dividing, we're going to take the powers away. 9 take away 6 is 3. So as you can see, this question was actually easier than the last one. It does look like it was more complicated because it had a mix of multiplication and division. But as long as you don't panic, do one thing at a time, then you're not going to have any issues. Just remember, do use big mass rules, but in this case, multiplication and division are on the same level of big mass, so it didn't matter which order we did them in. Now, for the final question, you can see that we have a root there. It's a cube root. So how does that tie in with the laws of indices? We've got a couple more laws to have a look at. So the first one is if you have a square root of x is equal to x to the power of a half. And if you have a cube root, like in this question, that's equal to x to the power of a third. Now, the pattern here is that the fraction, the denominator of the fraction, is how big the root is. So it's a square root. We don't normally write it in, but there is a little hidden 2 in square root that we don't normally write. If there's no number there, we assume it's square root. So we can see that a square root is 1 over 2, and a cube root is 1 over 3. So you can see the connection between the numbers on the root and the numbers in the fractions. This means we can rewrite the question. So we have x to the power of 3/5 multiplied by x to the power of 4/5. Now you can see in the question, the cube root covers the entire thing. And we also know that a cube root is the power of a third. So all we need to do is put brackets around the bit that was being rooted and then put a third on the outside since it was a cube root. So now we can start to solve the question. So we can see it's a bracket. We've got, that's going to be multiplying the indices, but we've also got inside the bracket a multiplication. So it might be easier to do the multiplication first. So again, we've got multiple things happening here. If you follow big mass rules, we'll do the multiplication first. So we've got 3/5 multiplied by 4/7. Now I've written down a multiply, but remember, if we're multiplying the base number, the x, we're going to be adding these. So make sure you use the right law of indices. I'll have to make these into equivalent fractions for this to work. So multiply each one by the other number's denominator. So times them by 7, we're going to have 21 over 35. Times by 5, we've got 20 over 35. So when we add them together, we're going to have 41 over 35. So now we can rewrite the question again. We've got our x, it's the power of 41 over 35, and all of that is to the power of a third. Now we can use our other rule of indices where we multiply because we have brackets, and we are going to do 41 over 35 multiplied by a third. Multiply together the numerators, it's 41. Multiply together the denominators, that's 105. So altogether, we've got x to the power of 41 over 105. Now, quite large numbers, you might want to think, can I simplify that fraction? In this case, you can't, but always be on the lookout for fractions that you can simplify. Now, before we move on, there's one more thing we'll look at, and it's the way the question's written. I just want to highlight the two terms that are underneath the root. Now, these can be written a different way using the final law of indices that I've not quite gone through yet. What we can do is we can rewrite x to the power of 3/5 as x to the power of 3, and it's the fifth root. And that's been multiplied by something similar. We have x to the power of 4, and it's the seventh root. And then all of that was being cube rooted. Now, obviously, that looks a lot more complicated. So the way it was written was probably a little bit better. But what's the law of indices I'm using here? Well, it's similar to the last two we looked at. If we have a number x and it's to the power of a and it's been rooted and the magnitude of the root is b, so it could be a 2 for square root or a 3 for cube root and so on, then that is the same as saying x is to the power of ab. So the numerator of the fraction power is the power on x, and the denominator is the root that's on it. This is a modified form of what you see underneath, with the square root being a half and the cube root being a third. In those cases, it's just that the power on the x is 1, meaning the numerator is 1.
Ouch. Love you too, Clem.